Okay, good morning. My name is Mike Franklin, and I'm with Kennesaw State University. And today we're going to talk about one of our programs, which is game development. So we have in our department a couple of different options: software engineering and game design and development. In our college, we also have computer science, information technology, and we have applied statistics and a few other statistical degrees. Each part of our college is integrated together around the idea of computing and the hardware and the software and the design and development of computing engineering software. So it's a lot of work we put together, but a lot of people in a lot of different disciplines, but they all work together to create what we call engineered data solutions, right? Things that do and work and perform. Today, I'm going to spend a few minutes talking about our game design and development degree. And I'm going to use a talk that we use when we talk about how we kind of get into it. Why do we do gaming at all? Why are we interested in this? And so it's a little focused on the tools for game development, but we'll use it as a way of segueing into kind of how we do what we do and why we do that. So we're going to talk a little bit about that. Thought I'd open up with a little bit of a video that's showing one of our events that we do. And this is from one of our previous game jams. What we do at least 3 times a year, hopefully 3 times a year, at least 2 times a year, we have a game jam. And we invite the community. Some people come as far away as North Carolina or Kansas or Florida up to our university. We stay there for 48 straight hours. Not much sleep is had. They look all bright and chipper now because they're checking in here. But during this event, we create a video game in 48 hours. So you're given a challenge to make a team. And this is what we do in this moment here when we have our big assembly. We're doing some introduction and giving people the floor to talk about who and what we are. But then we spend a little time making teams. And then you take that team and you are given a challenge to make a video game in 48 hours. So like I said, there's not a lot of sleep that goes on there, but it's a great time. Lots of pizza, lots of water, lots of running around, and a lot of incoherent babbling as we mutter in the corner as we crank away building a game in 48 hours. But this is a good example of something we like to do, which is not just teach, not just cover the theoretical, but at our university, we're very focused on the practical, the application of what we're talking about, what we learn, and how to use it. So one of our largest desires is that our students aren't just graduating with head knowledge, but they're graduating with experience. They've actually built games that are publishable. They've actually collaborated with teams that they've built. Many times we've encouraged them to build and make their own studios of people. So we help them. We have an incubator program that helps them to take their 3 or 4 buddies and they come together and they form a team. And we help turn that into an indie studio that can go out there and publish its own games. So we've had great success with that over the years. So this, to me, is one of the reasons we love Game Jam. Of course, it's a lot of fun, but that it exemplifies to me a lot about our program, and that is to really get you in the workforce prepped and ready. You'll see people doing some very, very simple mobile and casual games. You'll see people doing very complicated. We even had people build an arcade cabinet, so they built their own hardware. Yeah, we lots of pizza there. And you see people do a lot during these events that are about, we had a guy build an entire game on lasers. So it was a laser projection video game with collision detection and everything. It was pretty amazing. So we have a lot of people that do a lot of hardware oriented, a lot of sound artists, a lot of people that come together and collaborate. And all of it is designed and geared towards, very little sleep, by the way. All of it is designed and geared towards making a proper video game that you present, and then going on with that team, hopefully, and presenting that game and hopefully publishing it at some point in the future. So this is just a good example of something we love to do and talk about. It kind of gives you a good picture of what we do as a university, kind of how we feel about it. Our university supports this program, which is amazing. They let us live in their offices and live and sleep in their floors for 48 hours. It's pretty amazing. We have a guiding principle that talks about magic, right? So any sufficiently advanced technology is indistinguishable from magic. So that's an Arthur C. Clarke quote. What we do with game design development is magic, and to the world, that's what it looks like. Of course, from our side, it's just a lot of really great technology and a lot of blood, sweat, and tears that we put together to make programming happen. But why do we get involved in gaming? Well, first off, you might be involved in graphics. You really love the way things look. You like aesthetics. You like design. You like to bring kind of that idea of how do I express or create this new world that I want to share with other people, or I share this phenomenon, or how do I take people on a journey visually? So maybe graphics are where you are. And if that's where you are, then gaming is definitely the place to do that. We push the industry forward. In fact, the latest and greatest video cards for the longest time were driven by the gaming industry. I know now we have Bitcoin and people are trying to mine Bitcoin, but still that same technology only exists because of the graphics required for video game technology. So graphics is a great reason to get involved with gaming. Other people really love, we call it UI or UX, right? User interface design, human-computer interaction, the idea of how do humans interface with machines. How do I make it so that it really flows and works well? So user interface is of what it looks like and how it functions. User experience or UX is how the user experiences that, how we shape that experience for them so that they have a great time. As an example, in a video game, we want the person very much immersed in the game. We don't want them to stop and look at their keyboard. We don't want them to stop and look down at their controller. We don't want them looking around the room or doing something else. We want them drawn into the game, into the world that we've created. And so some people really get into gaming because they love that idea of how humans interact with each other via digitally and how we interface with technology, and they're very interested in that. Some people get into it because they like networking. There's no more densely packed version of networking other than a video streaming service than gaming when we have a multi-engine interface, right? We have a lot of multiplayer interfaces. There's global communications in there. So there's a lot of networking involved. So we have a lot of people that really love the hardware layer of gaming. They really want to understand how computers talk to each other, how they share with each other, how we get that information across, how we create games that can have that massively multiplayer online presence, and things like that. It's a lot of technical work, but people love that. So it's another reason to get involved in gaming. There's a lot of people that love the hardware and architecture. So I mentioned video cards earlier when we talked about graphics, but the way CPUs work, the way memory works, the way the architecture is related to each other. How do we maximize a game to run on a modern phone? How do we maximize it to run on an Oculus Quest 2? How do we create the kind of architecture we need to compete with a console platform or inside of our own computer? How do we maximize the efficiency of rendering engines and video cards? And there's a lot of hardware involved in what we do with game design, and it really pushes the envelope of technology. My favorite area, of course, artificial intelligence. This is what I do a lot of my work and research in, and we love AI, and AI has a broad application to the world. In fact, AI is a required course for our game design development students, but AI is really about understanding how to make a machine act intelligent, right? How to have it replicate or imitate human intelligence, and how can we make it appear to think and act intelligently. So in the game context, maybe that's with an NPC that's trying to interact with you and guide you. Maybe it's with a mentor character or a co-player in your team, or maybe it's the bad guys, right? How they think about where you are and how they find you and track you down, and can they make that game very engaging. I often say that AI in games is the hardest AI that there is, because every other AI in the world is trying to maximize or minimize. They're trying to go for the extreme. But in AI for games, you have to make an AI that's good enough to just barely lose. In other words, it has to lose or else the player gets very frustrated, but it needs to be hard enough to beat the AI that it's enjoyable. So it's really difficult to find that exact balance. Normally, like I said, in AI, you're just maximizing things. Well, you deal with data structures, right? You deal a lot with databases and data storage. How do I represent players in a game? And the data structure really applies a lot to efficiency with hardware. It applies a lot to networking with multiplayer games, and it deals with how we represent how we interact with humans and user interface design. So data structures are really at the core of what we're talking about. We also do serious games, so we do simulations, and simulations are about understanding how we can better illustrate or educate people or teach a principle or show a process using a computer. Don't tell anyone, my little secret here is that simulations, even though we call them serious games, they're really just video games, but don't tell anyone else that. So while we're getting paid to do serious work, we're actually just making a video game. But we have things like Flight Simulator that people have played, or driving simulators that are really rigorously designed. But we also have things that are helping people understand how to evacuate a building in case of an emergency, things like that. And then finally, algorithms. Algorithms are our magic sauce. It is how we think about how we interact with the world. How do we break down really complicated behaviors into simpler behaviors? Not an easy thing to do at all, but this is where we spend a lot of our time. We focus in on algorithms. So we like to think about graphics as environments and realism. How can we make this world and take you on a journey and create that? Thinking about weather as a simulation, right? This is a particle-based simulation, and it requires an AI. It requires a lot of the pieces of graphics and user interface to come together. Interface design is how do we interact with that machine using motion capture or touch technologies, or using something like the Kinect, right? How do we talk to the machine and give it input into our system? That's another area that we focus in on. Augmented reality, obviously we have a VR lab and an AR lab. We have an entire motion capture lab, and so we do a lot of work in this area. But this is a field that's really ripe and ready for the harvest. I mean, there's so much opportunity in this area. And it's a huge area for us to bring together graphics and hardware and architecture and data structures, a bit of AI, a lot of machine learning inside of that, and bring together something that's really interactive in a totally new way for players and people interacting with it. So then making games boils down into making, sounds and models and pictures and making decisions about how you're going to build it, what engine, and how you're going to distribute it out there. A lot of cool tools make our life possible. A little bit of Minecraft fun here for the nerds in the house. But really, your imagination is really the only limit to what you can create in the video game world. We love to create immersive worlds. Finally, I think the thing I want to communicate about game making for us as a program is that it's about storytelling. We want to tell evocative stories, and we're here, highlighting here Pixar, because Pixar has a really ingenious way to really draw you into their worlds that they create and really make you care about these characters that are really just CG characters, right? But they make you feel like they're real people. Like you really look at Wall-E in that bottom left picture and you feel what he's looking at when he looks at this faded Rubik's Cube, right? And it's really interesting to think about how we can tell a story that makes a difference. For us, we can tell that story for profit, for game making. We can do it for games for good. We can help the world be a better place. Really a lot of options that we can make happen for that. So with that, I'll just open up the floor for any questions that anyone that's listening might have.